Alright, in this video we're discussing section 9-5 on dilations, especially dilations that are in the coordinate plane. We'll also talk a lot about scale factors. Okay, by the end of this video, you should be able to identify and describe what a dilation is. You should be able to find the scale factor, pre-image, or the image length when you're given the other two. Okay, and also you should be able to dilate an image in the coordinate plane. All right, here's an example of a dilation. PQR, triangle PQR is the pre-image, and it's being dilated with center C. Okay, now I can adjust the scale factor, and if the scale factor is about 2, then then the image, all the lengths in the image are twice as long as the corresponding lengths in the pre-image. If the scale factor was 3, then all the lengths in the image are 3 times the length in the corresponding lengths in the pre-image. Okay, also, if it was smaller, like 0.5, then all the lengths in the image would be half as long as the corresponding lengths in the pre-image. Okay, now it could get really large or really small. Now, our book doesn't go into it, but it's possible that your scale factor could even be negative, and it flips around and changes orientation. Okay, but we won't get into that. Okay, another important thing to point out is if I took the length CP, I measured this length, and I multiplied it by the scale factor, I would get this length, which is actually how you would do it by hand. Okay, I would take CP, multiply by our scale factor, and I would get the length of CP prime. So CP prime is equal to n times CP. Okay, so if I take my pre-image length and multiply it by the scale factor, I get the length to the image. Okay, the same is true if I took this length and multiplied it by the scale factor, I would get this length. So CR prime is equal to n times CR. Okay? It is also true that, for example, the length QR, any length in the pre-image, that length times the scale factor would be the corresponding length in the image. So in this case, Q prime R prime is equal to n times QR. Okay? Now this is only about lengths. The areas have a different ratio, which we'll look at later on in the year. But the lengths, any length in the pre-image multiplied by the scale factor will give you the corresponding length in the image. Okay, the book defines a dilation this way. A dilation with center C and a scale factor of n being bigger than 0, again, we're not looking at negative scale factors, is a transformation with these two properties. One, the image of C is itself, so if you're dilating point C, the center, its image will be the same as itself, so C prime is equal to C. For any other point, for example R prime is on ray CR, and CR prime is equal to n times CR. We just looked at several examples of this formula. Okay, another way of rearranging that, if you divided both sides by CR, you get that n is equal to CR prime over CR. Okay, we will come back in a second and look at this formula, and it'll be very useful to us if you wanted to find n. Okay, also point out that the image of a dilation is similar, mathematically similar, to its pre-image. Okay, now looking at that same formula, n is equal to CR prime over CR, or in more general terms, n is equal to an image length divided by a pre-image length. Okay, just so you understand that idea, I've given 2 examples. Here the blue figure has primes on it, so that must be the image, and the black figure doesn't have primes, so that must be the pre-image. Okay, so the scale factor is equal to the image length. Now the only length I know in the image is 4. Okay, and the corresponding length in the pre-image is 2. So 4 divided by 2 is 2. Okay, so the scale factor is 2, which makes sense because if you take in the pre-image 2, multiply it by 2, you get 4. Okay, in this one, again, the blue is the image and the black is the pre-image. So the scale factor is equal to the image length divided by the corresponding pre-image length, which is 8, which 2/8 simplifies to be 1/4. Okay, so if you take the length in the pre-image, 8, and multiply by 1/4, you get the length in the image, which is 2. Okay, I'll also point out that the first example, this one, it's an enlargement. It's getting larger. And the second one, it's called a reduction. It's getting smaller. Okay, and that corresponds with the scale factor. If the scale factor is larger than 1, it'll be an enlargement. If the scale factor is between 0 and 1, it'll be a reduction. Okay, the blue figure is a dilation image of the black figure, and the labeled point is the center of dilation. Tell whether the dilation is an enlargement or a reduction, and then find the scale factor of the dilation. Okay, number 1, again, the blue is the image, and the black is the pre-image. So it looks to me like this length is 4, and this length is 8. It's not labeled super clearly, but that's kind of what I'll think of it as. Now the length in the image will be 12, since it's 8 plus 4, and the corresponding length in the pre-image is 4, and so 12 divided by 4 is 3. Okay. Number 2, the length in the image is 12. Okay. And the corresponding length in the pre-image is 8, so n must be equal to 12 over 8. Okay, which that simplifies to be 1.5. Okay, whatever it is, it's equal to the image length divided by the pre-image length, and that would give you the scale factor. Okay, a few more examples, make sure you really understand it. This length is 2, and this length is 4, and the scale factor is the image length over the pre-image length. Okay. All right. Now dilations in the coordinate plane. Now in this class we will only look at dilations with a center of 0, 0. Okay. And the scale factor we'll call n. Now we talked about a little bit ago that whatever this length is, if I multiply it by n, I get this length. Okay. Now, if we look at that specifically in the x direction, then this length is x, and it turns out that this length here is n times x. Okay? And this length here is y. Okay? And if I multiply by n, I get n times y. Okay? So, if I take any point, x, y, and I dilate it with a scale factor of n, I will get that p prime is nx times ny. Pretty simple formula, but I hope it makes sense. Okay, so if a dilation has center 0, 0, which they all will in this class, to find the image of each point for the given scale factor. Now just multiply each coordinate x and y by the scale factor. So d prime will be equal to 1 times 2, which is 2, and negative 5 times 2, which is negative 10. Okay, number 2, t prime will be 0 times 1/3, which is 0, and 6 times 1/3, which is 2. And 3, m prime, 0 times 10 is 0, and 0 times 10 is 0, so it's 0, 0. Okay, now let's actually do it on the coordinate plane. Now I will take each coordinate and multiply by the scale factor. We're using a scale factor right now of 3. Okay, so z is the point negative 3, 1. I will multiply each coordinate by the scale factor. So z prime will be equal to negative 3 times 3 is negative 9, and 1 times 3, which is 3. So z prime is equal to negative 9, 3. So if I graph that point, it's right here. This is z prime. Okay, let's do p next. P prime will be equal to 3 times the scale factor, which is 3, and I get 9. And 0 times 3 is 0, so P prime must be 3, 0. It's P prime. All right, G is 0, negative 2. If I multiply each coordinate by the scale factor of 3, G prime is 0, and negative 2 times 3 is negative 6. So I graph the point 0, negative 6, and that is G prime. All right, now if I connect these, I will get the image under the dilation with a scale factor of 3. One more, just let you know that you can still do it with fractions. It's the same idea. I'll write the coordinates of Q, which are 0, 3. Coordinates of P are negative 3, 0. Coordinates of R are 1, negative 3. Okay, if I take each coordinate and multiply by the scale factor, I'll have the coordinate for the image. So Q prime is 0 times 4/3 is 0. 3 times 4/3 is 3 times 4, which is 12, divided by 3, which is 4. Okay, so Q prime is 0, 4. It's right here. P prime is, let's see here, negative 3 times 4/3 is negative 4. 0 times 3/4 is 0. R prime is here, 1 times 4/3 is 4/3. As a decimal, it's 1.3 repeating. And negative 3 times 4/3 is negative 4. So R prime is right here. So if I connect them, oh, I never graphed P prime. P prime is right here. If I connect them, I have the image. Okay, some related questions is you look at each object described in 1 and 2 under a magnifying glass, and you're given the length in the magnifying glass. Find the actual dimension of each object. Okay, the image of a button is 5 times the button's actual size, and the image in the magnifying glass is 6 centimeters. How big is the actual button? Well, if it's being 5 times larger, and what I'm seeing is 6, to go backwards, I'll divide by 5 and get 1.2 centimeters. Okay, so if I take the image length and divide by the scale factor, I'll get the length in the pre-image. Okay, the image of an ant is 7 times the ant's actual size and has a length of 1.4 centimeters. So I take 1.4, that's been enlarged 7 times. So if I divide it by 7, I'll get the actual length of the ant, which is 0.2 centimeters. Okay, a magnifying glass shows an image of an object that's 7 times the object's actual size. So the scale factor of this enlargement is 7. Okay, the photo shows an apple seed under this magnifying glass. What is the actual length of the apple seed? Now, in the picture, it's 1.75 inches, and it's been enlarged 7 times. So if I divide by 7, I get 0.25 inches. So the actual seed's length is about 0.25 inches, a quarter of an inch. Okay, so that's discussion on dilations. Hopefully you understand at least what a dilation is, and also especially in the coordinate plane. Hopefully you understand what a scale factor is and how that relates in a dilation, and also enlarging and reducing. And I'm hoping that you can find the scale factor, pre-image length, or image length when you're given the other two, and I hope that by now you can dilate an image in the coordinate plane.